Hey everybody, this is Larry. This is me going with Q4 of the Bi-Weekly Contest 99. Count number of possible root nodes. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this problem is at its root, get it, a recursion problem, but it's very tricky. As you can see, I took half an hour on this really, I think this is a difficult problem, not insurmountable per se, but I would also acknowledge that, and this is just something that I know from, at this point, decades of competitive programming experience and stuff like this. And what I mean by that is just that I know to some degree what I'm good at and what I'm not good at. And this is something that I would consider as one of my weaker points. And I say this not because of something that is innately like, oh, I just suck at trees per se. I mean, maybe you could say that, but what I mean by that, not to discourage anyone, is just that you kind of have just like this zeitgeist of how good you are at something compared to people at your level or people who are even like slightly better than you, so you can make that progress. And tree problems are honestly like one of my weaker points for the reason that I think in certain cultures and certain learning institutions, trees and recursions are given a lot of emphasis. And me, for someone who self-learned a lot of this stuff, when I was younger, I didn't put that many reps into tree problems as someone who has the same rating as I am or someone like this, right? Might have, right? And in certain, and what I mean by that is that, and apologies if you're just looking for this for the explanation, you can maybe fast forward a little bit. I'm just talking some historic competitive programming things. I think in the past there are, if you're like more academic, then you may have practiced more tree things, but I never did, I guess, or not never did, just not as to the level that people say my skill level would have, right? So I always knew that this is a little bit weaker, and it kind of shows up in the results today, because I have to reproof and refigure out a lot of things that a lot of people take for granted. Especially, and this comes into play a lot with respect to things like having a really good understanding of the bridge algorithm and the articulation point algorithm and the strongly connected component algorithm, right? So all these things are kind of related in that, I mean, they're not trees, but just like this this idea of using recursion and depth first search, and having like this thing, it's very useful in a lot of these problems and a lot of things that people take or the more academic people who did a lot of these problems, they were just very good at it. And for me, I'm merely only okay at it, I suppose. In any case, so that's kind of the context behind this. And the reason why I brought up articulation point and bridges and stuff like that is because even though it's not quite directly true, it's just about directly related rather. It's about figuring out, in those cases, it's about back edges. In this case, I think I called some stuff back edges by accident, but it's not quite technically true. It's just about figuring out the states that you can get, it's possible, at each point, and then also figuring out what's a quick way to get to those points, and then in a way, it's about asking the right question at every state of the point, right? I think that's maybe a way to kind of think about how to approach these problems. And for me, that's I'm not as practiced as I used to be as well, but so definitely this is just funky to me. That said, anyway, sorry, it took a couple minutes of me kind of talking about the background of this problem for me anyway. Hopefully maybe it's interesting. If not, then send it to someone you don't like and make them watch it. But no. Okay, so I would say the first thing about this problem is that I honestly, during the contest, I misread this for about 10 minutes, so that's very sad. The thing that I misread is that I didn't realize that U and V has to be a direct edge in the tree. I think the first time I read this problem, I misread it as just there exists a path, right? Meaning that in this particular case, one of the guesses maybe could be from 0 to 2, even though they're not directly connected. Because or they're connected, but they're not. There's no direct edge, and I think I misread that, and I was just trying to figure out how to do like some LCA type thing. LCA being least common ancestor, like maybe binary lifting. And if these terms mean nothing to you, it's probably fine because they're very high machinery for most people, and definitely out of scope for interviews in general. But that's where my mind was at because I misread the problem for quite a long time. Also, some of the phrasing is a little bit weird, but that's just me being pedantic because, like, in one guess he does the fine, but like, this should be phrased a little bit differently because it just, I don't know, in my mind, maybe I just read it a little bit awkwardly because it sounds like it's taking this as fact, even though it's more like, you know, just telling them about, or like this is a query, not, you know, I don't know. Phrasing is a bit weird about telling, right? In any case, because now UV has to be an edge in the tree, this makes it more tractable. And this is the way that I would think about solving it. Or I did eventually, but I took a while, just to be clear. So yeah, I'm kind of stalling a little bit because I'm trying to pull up the drawing stuff. So I could kind of draw a tree. So basically, the way that I thought about it is kind of, and this took a while, just to be clear. So you know, don't, you know, I think one thing that I get annoyed at sometimes is that, or not annoyed that much, but I think some people have unrealistic expectation on what solving a problem is like. And what I mean by that is that when you look at these videos of people explaining their problems, and there's always this perfect explanation of like, oh yeah, you just do A and then you just do B and then you combine A and B and then you do C and, you know, obviously, and then everything is easy, right? But you know, each step of the way is actually kind of hard, and that's, you know, that's one of the reasons why I like doing these videos in this format, even though maybe it's not as, you know, precise and to the point. I want people to realize like, this is hard and it's okay to struggle. I'm struggling and I'm like, you know, pretty okay at this, you know. So yeah, anyway, so you have to, you know, oh yeah, one thing that I would say is, before I get into it, is that you look at the constraints, right? The constraint is 10 to the fifth for both the queries and the number of nodes in the tree, the size of the tree. So you know that immediately, n squared is not going to cut it. There has to be a O of n algorithm, or O of n log n, if you will, algorithm, right? So that's just the meta thinking about this problem. And from that, the other kind of obvious thing, or not obvious, you know, maybe, but one thing that you get from experience from that is that you know that you can only afford to traverse the tree once, or a constant number of times rather, right? Meaning that you can't do some like, oh, let's just do a depth first search on this node and then that node and then that, you know, you can't do that. At least not, maybe there's some amortized way of doing it, but not for this problem. I'm just saying in general tactics, right? So anyway, so you have this node, or you have this tree. I'm just going to do the one from example, actually, right? And then the idea is that now you have some edges that can only be true if it goes in some direction, right? So that means that, for example, let's say we have a guess of these two nodes, then that's basically what this is saying, right? It's either that this is the, if you're guessing that this node is the parent of this node, then that means that you, on a regular depth first search, this is, on a regular depth first search, and you're going from this node going down, this would be the way that is, you know, with that direction and so forth, you know. And if you do a depth first search in a rooted tree from one root, it's only going to give you one unique depth first search tree, right? So then the first part should be kind of easy, maybe, which is which is just count the number of, for each node, we want to store number. I thought I changed colors. Hang on. For each node, you want to store the number of correct guesses, which is the things that are in your direction at each node. So here, I mean, this is a leaf, so this is 0. This is 0. Now let me just draw a couple of more edges, and then maybe like one going backwards, for example, and even one going forward, because that could be a thing. Anyway, so this is also 0. This is 2 because there are 2 green edges going out, right? And then this is 3. So that's the first step, and of course it's not complete because well, oops, what happened? This is not complete because, well, yeah, you don't count the back edges and stuff like this, and you don't count things going in the other direction. So that's basically the way that I thought about it, but I got this first, right? Yeah. And this is kind of tricky, to be honest. That's why it took me a while. So I'm just trying to think about what's the best way to explain it. But I think this part, hopefully, everyone makes sense. It's just the number of down arrows from tree. So then that's the number of guesses that are correct on this node. But then there are things about what I call back edges, but it's not really back edges in the tree sense. It's about like, these edges that go backwards, right? And for me, for that, it's just about, okay, let's count these, right? And now I'm going to do a second depth first search, say, and then count them going backwards. So now instead of going here, propagating up the answer and then summing them, right? That's how we would do in a regular depth first search ordering. The second order maybe, and I'm going to change the color, is that in a way, instead of pull, maybe it's a push. You can think of it that way. So here, now we start with 0. We encounter one we go down, we encounter this edge going backwards. So that means that now here, now we pass in a 1. So then now we know that, going in, that the number of back edges, then now you can sum it up, right? So now this is a 3, ... and this is a 1, this is a 1, this is a 1, right? Just because, you keep on passing in the number of edges that go against the current, if you will. So that also is not enough, but it's a start. The reason why it's not enough is that there is one more case that you have to consider. I'm trying to find it. I've been using up colors. Maybe yellow is fine, okay. But for example, this node, right? Yellow is ugly, or like it's too bright. Okay, well, this is going to be a short yellow. But the idea here is that, how many guesses are actually in here? Well, there's 0 going this way. There's 1 coming from this direction all the way from root. But what about the other direction? Meaning, given this parent, the other branches of the tree, right? So maybe if you could draw another tree where it looks something like this, maybe a star-y thing, right? And let's say that you have all these things. So how many correct guesses are if this thing is a root? Well, if this thing is a root, then you want the sum of all the nodes from here minus this portion, right? So this is a technique that actually comes up quite a bit, and I am not good at it, but I am getting enough practice just because of Leetcode, I guess. So I mean, I am better, but I'm still, I wouldn't consider myself good. But yeah, but that's basically the idea, is that you store the numbers in such a way that you get the number here. So you have some sum here minus the sum of all these components. Sorry, let me use different colors. These colors are basically, the idea here is that, okay, so yeah, this node contains some sum, right? And then you have this node that contains some other sum, like let's just call it A of 1, A of 2, A of 3, right? So A of 1, and let's just call this A sub 0, right? A of 1 plus A of 2 plus A of 3 plus A of 0 is equal to some sum. This is terrible math, by the way. But yeah, but you can see that from here to get this, the total of these three things is just sum minus a sub 0, right? On the right side. I know the notation is poor and the drawing is like some abstract art at this point, but I hope the explanation kind of at least gets you to a point where we can go over the code. And the code is actually, you know, okay. I wanted to say it was cleaner, but maybe not so much, to be honest. Yeah. What was I going to say? Yeah, so basically, okay, first of all, this is just converting from an edge list to an adjacency list. And this is just to make that the guesses look up, you know, to see if an edge has any direction, just constant time, right? Or maybe log n time, but, you know, faster lookup. So here is the first thing. It returns the number of nodes that are, the number of guesses that are down DFS tree, down tree from node 0 for each node. So that's, you have to root it at each one. It doesn't, or one node. It doesn't matter which one, right? But yeah. So that's, and this looks like a very straightforward recursion. Basically, for a tree, you basically just sum up all the subtrees answers. You add one if the edge that you're going down right now is in the guesses in the right direction. And then the second one is a little bit trickier. I mean, this one does two things. So that's why maybe I could have separated this out to a third one in the three ways that we can explain it. But basically, counts is the thing that we, as we said, is propagating the number of against current edges, right? So count is equal to the number of against current edges for each node. And as you can see, as we push through the current, we just add it to counts as in that way. And here, yeah, and here is kind of, I mean, we did some maths here to kind of count the number of things. We have to also subtract the one that, you know, we just, we want to propagate down not just the back edges or the against current edges, but also edges that are on the other side of the tree. And that's basically what this does, right? This is what we had visualized as, you know, remember the sum minus the other edges, right? Or sum minus this edge equals the sum of the other edges, right? So, and that's basically what this is. G is equal to the number of guesses that are correct. So the number of guesses that is correct for the parent minus the sum of thing for the other, for the guesses that are on your side of the edge, and that's basically how you do it. This is to account for if you have an edge going, if you have a guess going down this way, you just don't want to double count it. That's why you have -1, and this is just to count the against current edges. So you add one in that direction. So we run the recursion, the depth of search twice, and then we just count the number of things that are bigger than k, and that's it. Make this a little bit smaller so you could see more of it. It's even smaller. Wow. Hope you could see it. Hope you have a good monitor. But yeah, but this is just two depth of search, so this is going to be linear time and linear space because we have to do an adjacency list and maybe a lookup list. And linear in this case, of course, is n times g, where g is the number of guesses as well, just to be clear. And given that this is a tree, the number of vertex is roughly the number of edges. That's why we said it like this. Cool. That's all I have for this one. Let me know what you think. I mean, I think conceptually it is not that hard to understand, but don't let me fool you. Writing this from scratch was hard, at least for me. And you could kind of see how I do it during the contest in the next portion. You could fast forward a little bit toward the end if you like, because I got the core structure. I wouldn't say quickly, but I got the core structure, but it still took me a lot of time to kind of be like, okay, Larry, what is it exactly precisely that you want? And I was off by a little bit in places. So yeah. Anyway, you can watch me sub a live in contest now. Let's do a YOLO. So many silly mistakes today, but okay. That didn't cost many penalties yet. Okay, you have a tree, 2D array, okay. That's a game. Is there a mod? No mod, okay, just want to make sure. Whenever I say count, I check one mod these days. Okay, in one guess, choose 2 distinct UV, and he tells Alice U is the V of parent. Oh, U is the parent of V. What the? This is some like abstract things. How am I doing anyway? People got it ready. People went, wow, 4 minutes. Yeah, I mean, I guess I can understand that actually. This wasn't that bad. But I mean, the tell is kind of, the English grammar is a little bit poor because it was very confusing. It should be that it is a guess that it asks, not like tells him, not like Bob is answering. But okay, anyway, okay, what is it going on? That means that given these things, at least K of these is true. How many number of trees are there? Well, it's scattered at numbers. I think. Could be wrong actually. Well, maybe it's wrong, I don't remember. And n is something big, right? Yeah, okay. Just should double check that first instead of like some n square solution. Wasn't thinking about it, but now we have to do something linear. Linear. Okay. Can't even do DP. Possible root. Someone cut it already. Wow, that is impressive. I lost a lot of time on Q1. I guess it's just whether this is possible. Right? What does it mean for it to not be possible? Because it's just that this is the root. Right? Okay, let me think about this. This is a little. Let me write out edgeless. Okay, and then basically. Not all these can be true, right? Because these two are mutually exclusive. So if 0 is the root, what does that mean? If 0 is the root, then do we care about this? You know that this could be true. The only way it's not true is if, I mean, a lot of people got a lot of wrong submissions as well, so I don't know that my first intuition of greedy dumb is correct. But because there could be some parenting thing. What does that mean for me? I mean, let's say if 0 is the node, but there could be some transitive property E thing. Is that true, or is it just any pair? Oh, this is it's not just any, it's just specific, right? So then now 1, 3. So just some like maximum no, I won't say maximum, but just some bipartite thing. So 1, 3 means that only one of these is true, right? Obviously. But then it also means that given this structure, I don't really have an idea yet. Can we do it for one number first? 0, 1, 8. That means that. Can we do it for the guesses? Parsing the guesses. So that means that 1, 3 is, let's say 1 is on top, right? And 3 is not, obviously. And 1, if 1 is the root, then some of these, like 2 to the 4 is true. But then if when is 2, 4 not true? Huh. People got it already? People are really smart. Are these edges? Oh, these are all edges. I think I missed that. Oh wait, no, they're existent. Wait, what? So this, no, oh yeah, these are, okay, so, oh, damn it, I misread this. Okay, so does that mean anything? That means that for this 1, 3, we can count. People are getting it though, so I think I'm just being not smart. But all these are edges. What does that change? How does this change? Guesses can be any number, though. And 3 palms are always my reducer. Okay, so 1, 3. That means that. Oh wait, no. Okay, 1, 3 means that if this is true, then what does that mean? That means that everything to the other side of 1, 3 could be a root, right? Okay. Now I kind of get it. Right? But then how do you do that in linear time? Right? Or if we do the guesses and then we do that first search, what does this mean? We see the nodes on the one side, but you'd have to do accumulating on all the nodes before, right? Okay, let's say we people are getting it faster. I don't know. Kind of relatively quickly. I do it. Okay. Okay, so we can do that search, but then is that enough? Yeah, okay. I think I got it, maybe. Okay, I think I got it then, maybe. How am I doing? And then, yeah, okay. Okay, and then basically okay, so for we in node and okay. So we, what does it mean if we pass through one of these exactly? So if we pass through one, that means that we've seen one edge. Okay. Do we add counts? If node we is in lookup, then what do we do? Well, we want to do this anyway, but else. If there's a back edge, then no, if there's a forward edge, then it's this +1. And then if there's a back edge, I may have to do both actually. This is kind of weird. And then something like that. I don't know if that's quite right, but I mean, I'm definitely probably off by some stuff and it's not right, so it certainly is. But the idea is right. 3, 3, 2, 1, 1, that's really wrong. 1, 2, 3, 4, 3 is better, but my other thing is my back edge is 1, 3, 3, so root is 2, right? Basically, my tree looks like this, and then basically it goes 0, 1. Oh, this is 0, 1. So for 0 to be 1, then 0 has a +1 here already. Yeah. And 1, 0, so this is 1 going down, and then 1, 2, 2, this. Oh, what do we do about numbers that don't matter? Huh. Because basically 1, 3, I see why this is a little bit off. Because basically it's just not in the chain that we've seen before. We want to tell 2 that there's 1 here, but then it also has all the other ones that we don't care about. How do I handle that? Because basically now it's just passing into 1. And 3 has that 3. Yeah, I don't pass in the 2 side as well for the 2, 4. So this isn't quite right because I don't consider all the other branches of the depth of search tree. Does that fix it? Fix it for this, but oh wait. Well, this is just really wrong in any case. But I don't. I gotta stop biting my nails. And the order also matters. That's the kind of confusing thing about it. Had to do a breadth search? No, because then you still have to go through the tree. Well, I mean, maybe, but at least not the way that I'm thinking about it. I think we maybe just need 2 depth of search. First one for the forward edges, and then don't care about the back edges. Okay, what does this look like? Okay, Okay, so 3, 2, 1. Okay, and then do we have out of back edges? Yeah, maybe. Maybe. Nope. Oh, I don't have to. I didn't call it, so of course it's not gonna work. No, still not quite right. I've just been kind of lazy on this one. Okay, so the recursion. Oh, this isn't E of parents. This is G of parents. Nope, still very wrong. What do I want? Right? I think I want the same idea as before, but now. I don't know that this return does anything actually. Right, okay, but then now we also want, so this is basically what we had before. Oops. But then 2 of them. And now we want to convert these to be no, I think this is quite right. What am I trying to express? All the other numbers that are not in, right? So it's just minus G of V. Something like this. Okay, maybe not. Basically, it's just trying to say how many queries are on the other ones, right? Struggling this one. It's saying, for example, for the 1, it's saying that there's one thing that you don't care about on the 2 side, and there's one thing you care about on the 3 side. Pass it over. So what am I doing here? Well, this is just the number of guesses total for this side, right? So why is it not just, why is this not just G of, oh, because of this thing, maybe I have to do it at the end. Nope. Okay. Node 1. We look at V, that's 2. Let me pass on 2 going down, right? Two. Two, we have count of 3, which is off because should only be 1 on the other side. So it was saying that here there's 3 total queries minus here the 2 total queries on the other node. Yeah, so it's 1, but then count is what is this count? It starts at 0. Why did it get 2 by the time it's here? Oh, there's 1 back edge. That's why. And because on 0 there's 1, and then this double counts it maybe. No, that's not true, right? Yeah. What is going on here? Yeah, why this counts 2 by the time it's there? There's only 1 back edge. And then this because it double counts this thing. Does that help? I mean, it solves this issue, but I don't know that this is enough for me to convince that I'm right. And it is right for the sample, but alright, let's get YOLO. I mean, I'm gonna get a wrong answer and maybe hopefully get, I was hoping to get, I mean, well, I wasn't hoping, but I was hoping that if I was wrong, Ayush, congrats Ayush. I was hoping that if I was wrong, I get a quick wrong answer. Remix, wow, congrats Remix. I mean, I don't know. I mean, okay. I was gonna say I think China's not factored in, but either way, that hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem and this explanation and this contest. Yeah, stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.